Hi folks, welcome. And in this video I want to show you my next attempt at realizing drone quickshots and ArduPilot based vehicles. And I showed you such an attempt, or the results of such an attempt, which I made a couple of months ago. So I put out this video here, and in this video I was showing that it's basically working what I did, but to quote myself, it was not working very well. So what this means is, it was good enough to show it, but it was not something really usable in practical terms. And how I was explaining this to you was as follows. So what I did in this earlier attempt was that I took an OpenTx transmitter, loaded it with my OpenTx for Muffling firmware version, wrote a proper Lua script, which made it then to send Muffling messages over the air to the flight controller, which was then controlling the vehicle. And the problem in here is that the rate at which one can send these Muffling messages is of course very limited. It was very slow, and the link is also not very reliable. And this made it that the copter was not really moving very smoothly, but like so. So this was not perfect. What I've also told you what one should do is, and this is actually not my idea, this is how people are doing it since many years. And anyway, so what one should do is the following. One should use a companion computer on the copter and only send some generic information via the air, such as start, stop and set and such things, but that all the heavy lifting and all the heavy work should actually happen in the companion computer. And the companion computer is then connected to the flight controller, again via Muffling messages, but these can be exchanged now very fast. For example, in the case of a 3DR Solo, it's done at 25 Hertz. And so you have a much faster rate, which means a tighter control of your vehicle and therefore much smoother movements. And this was exactly my plan to do in the last months, or basically since ever, right? Because this looked just to be the way how to do that. However, there had been another development, namely that ArduPilot now provides Lua scripting. And just to make it clear, we need to be a bit careful here. We have now Lua script running on our OpenTx transmitter. And what we're talking about here, however, is a Lua script directly running on the ArduPilot flight controller. So we have now two Lua scripts in the game, and we should not confuse them. What I'm talking about here now are the Lua scripts which are running directly in the flight controller, in your flight controller. Now in this Lua scripting, I was saying, okay, that's great, but I didn't took it really serious. I was thinking, okay, that's really cool to have, and you can do all sorts of things like driving some LEDs or making a customizable display or beeping or driving some servos to release some things and so on and so forth. For all these user desired things, such scripts really are fantastic. But these are all tasks which basically are running at a relatively low rate. But I was thinking, okay, but for controlling a vehicle, the flight path of a vehicle, this didn't look like they can do that, right? But then Randy McKay came out with this script here, and he also showed a video which he called the fly vertical circle. And what he was doing here is that the copter was flying up and then made a circle like this and landing again. And I was saying, hey, wow, that's interesting, right? That's at least something, but I wasn't really impressed because I looked at the script, and then I saw this number here, namely this 100 here, an update rate of 100, which means an update rate of 100 millisecond, and this means 10 Hertz. So I was saying, okay, nice, but not really a reason to give up companion computers, right? And then they, in addition, also had had some time scheduling issues with the scripts and so on and so forth. So I was saying, maybe. But then Randy McKay came out with this script here. I'm not sure he has shown a video, but at least there's the script, and it's clearly working, which he called the wall climber. And I was also looking at it, and then I saw this number here, an update rate of 10, which means 10 millisecond, which means 100 Hertz. And this number really is the number which got me. 100 Hertz, that's really something you cannot easily do with a companion computer. I'm not sure if it's even possible, but I mean, in case of a companion computer with a serial link, you're talking typically about 20 Hertz or 25 Hertz, maybe 50 Hertz, but I mean, maybe 100 Hertz is possible. I don't know, I have never tried it, but I mean, this is really a stretch then, right? So meaning 100 Hertz, that's really a statement. And this really attracted my interest. And please note, I mean, you have additional advantages from that. You don't only get this 100 Hertz, you also have no latency. You don't have to communicate anymore through the serial link, right? I mean, there's no latency anymore. You're directly talking to the controller in your flight controller. And for the same reasons, you have all the benefits because you're not limited anymore by the Muffling API. You're not limited if something is provided by the Muffling API or is not. And I mean, the Muffling API is nice to have, but it's really, right? So I mean, this is great. You now can directly talk to the controller. You can have it doing exactly what you want to do. I mean, this is really very promising, right? And then lastly, of course, I mean, you don't need all this stuff anymore. I mean, maybe such a big thing is not what you need. Maybe such a smaller thing is sufficient for you, but nevertheless, I mean, you need to put it on your copter. You need to power it up. You need to have some power supply. You need to somehow establish the connection, all the serial links. Then you also need to install the firmware and maintain and write the firmware on the thing. So, I mean, you don't need this anymore, right? You just do everything in your little flight controller, which you have there anywhere. So I really got hooked by this number and this idea to do the drone shot by this script. And the question was, is this possible? Well, you might guess I would not show you this video if it would not be possible. So it's possible. And what I'm going to do here is that as next I will show you a short brief video of a flight as a snippet, just to show you that this is working. And then for the rest of the video, I will go into the details because you can't use it out of the box. So there are quite some things one needs to do and so on. And I want to talk about the technicalities and how I've solved it and what comes into that. So, ich werde jetzt den hochfliegen, also starten lassen. So, dann fahre ich jetzt die nächste Position an. Drehe den Kopf ein bisschen und ich brauche die Kamera. Das müsste ich jetzt mal, wenn Sie mal ganz nah rangehen, dass Sie die Kamera sehen. Die Kamera. Dann kommen wir wieder her. So, jetzt tue ich da das setzen. Den Punkt. Und jetzt schalte ich in das Cable Cam. So, und jetzt müsstest du sehen, wie ich hin und her fahren kann. Und eben auch wie man sieht, dass der Kopter dreht und die Kamera sich dreht. Was jetzt sieht. Hier auch mal einen Stick schauen, was da passiert. Hier mal drauf schauen. So, nochmal filmen vielleicht. hier wieder. So, jetzt schalte ich es aus. Und das war's. So you have seen now the video, and I hope you could see what it was supposed to show. You should have seen three things, namely first that the copter was moving along the cable, then second that the copter was yawing while it was moving along the cable, and third you should have seen that the camera was pitching up and down while it was moving along the cable. Now, as already indicated, for the rest of the video, I'd like to discuss a bit the technical aspects of what you just have seen. And there are actually quite a number of different parts which need to come together here in order for this to work. So first, of course, you need to have a transmitter. It was running with OpenTx with Muffling firmware. And I was using a special version of this Olli W telemetry script. Then we of course need a flight controller and a flight firmware, and this here was using BetaPilot, so it's a version of ArduPilot with all the extension which you need here. And then of course a Lua script which is running on this flight controller, and then of course you need a gimbal. Here I was using a STorM32 gimbal controller which was communicating via Muffling with the flight controller, and here too one needs a proper protocol, and I will talk about all the things here. And then lastly, of course, one needs to have a flight controller. And that's actually a topic to mention too, or to briefly mention too, because with the scripting, it's very resource hungry. So you need RAM, and you also need, so to say, the microprocessor cycles to execute the script. And on a F4, I think this is not possible to do. So, I mean, the F4 is very limited with terms of RAM. With an F7, all this possibly works. I don't know, but I got me an H7 because I just didn't want it to have any issues here. So I just took the one which has by far the largest memory available, largest RAM, and so just to get out of it. And it's also sadly that ArduPilot is not really looking carefully for the RAM consumption, so it's not too difficult to configure an F4 to behave in weird ways or even to crash because of RAM limitations. So I just took an H7, and then an H7 is also by far the fastest. I mean, F7 is not very much faster than an F4, but an H7 is much faster. So this was so I just took an H7 to have no issues with all the scripts. Then another issue is the flight controller firmware and the possible Lua scripts you can run on that. And this runs under the term bindings or script bindings, and most of the script bindings which are needed by this Lua script in order to do this Quickshot are not yet available. However, it's not difficult to add these script bindings. So this is here the GitHub page which just this file which defines which script bindings are available. So there's this list here, and it's really amazingly simple. I mean, you just have to define your function or write your function, then add it in here to this list, and then you just have to recompile, and your script can use this binding. So this is really fantastically well made. So really big thumbs up whoever has done that. That's fantastic, and that's really super easy. So the whole thing I had to do here is basically to write the script functions right in the code, and then to add these bindings, and then I had available what I needed. Now another not so nice thing is that you run, in order to get the control of your copter, you run in guided mode, and guided mode is really around for so long, and one really would think that it would work better or would be a bit more powerful. For example, I'm using a rangefinder to have a good height, but it somehow seems not to be used properly, and so on, and the interface is somehow weird. So anyway, we have to go with that. That's so it's available and it's doing something, but I would have hoped that it would be better. And then another aspect is of course this communication in between here. And this is really something one needs to think carefully about, because you have a script here and you have a script here, and you need to get the communication working, and in particular the two parties always need to be in sync. So even if something goes wrong and so on and so forth, and I'm not claiming that I have completely solved it and so on and so forth. I just want to say that this communication here needs some thought. And the way of how I did that is, I mean, one should have defined proper muffling messages here, right? But this was not what I wanted to do. I wanted to do it just as simple as possible. And my solution is as follows. That for the communication from the transmitter to the flight controller, I'm using the button change function, muffling messages. So I'm sending here some muffling messages, and when I changed the code, ArduPilot code, such that this muffling message is used by the AP button library. And the good thing was that there was already a script binding. There is already a script binding to read button changes. So I just had to hook in this muffling messages and could then directly use this. So the actions on the transmitter, which you have seen me doing, they are communicated to the script here or to the flight controller by this button muffling message. Now for the communication from the flight controller back to the transmitter, so what's going on and so forth, I took an even simpler approach. Namely, I took the status text muffling messages, and this is already completely implemented already in Muffling and in this in ArduPilot and in the scripting. And I simply, what I did, that I gave the messages a particular name, Quickshot, and then something after that. And in the transmitter script, I was then filtering out just all the status test messages with this particular header name, and this I could then use as a feedback. And this is something I'd like to show you actually briefly by a debug or test case. So what I have here is now the following. So that's the transmitter, and this is just a test setup. So I have a transmitter here. Here I have a flight controller. Here I have a gimbal, and they are connected now. Or actually, the flight controller is not yet connected, but the flight controller is connected to Mission Planner, which is connected so we can see what's actually happening. And what I'm going to do now is quickly that I connect the telemetry link. So it's not via the air, it's just by using our cable. So when this comes here, and that's what you also have seen in the video, when I can switch to this page here, I can go to the cable cam, quick shot. So I'm here now in this page here, right? And when I'm pressing now this button here, this muffling message is sent to the flight controller, and then as a response it tells us that the point has been set. So the point is actually set in the flight controller and not in the transmitter, and you can see this here. So I'm pressing this button now, and you see that the script has sent back this quick shot point A information. And when I'm pressing the second button, then the script has set the second point and informs the transmitter by this message here. And when I'm starting this here now, you can see what's happening here. So the script has gotten the information that it started, and then it feeds back all the time at which position the cable is. So that's this information. When you look here at this point and I move it now like so, when you can see that this value is feedback to the transmitter. So that so you can see this always like that, going like that. And when I'm stopping it, pressing here,
position, hold flight mode,
you will see that this has stopped. So that's a very simple approach for this communication. As said, one should do some proper muffling messages, but it's actually working fine. And the good thing is, because it's mostly using standard messages, it's good for debugging and so on. So I mean, you can see it in Mission Planner and so on and so forth. Another thing is, which one needs to get right or needs to get into control is actually the communication between the flight controller and the gimbal. And for that I've designed a new protocol. I'm calling this the STorM32 MAVLink gimbal protocol, and it's actually coming out of a years-long discussion with the Muffling guys concerning a new gimbal protocol, and this is then here my particular version. So there's a STorM32 XML which defines all that, and it defines the communication for the gimbal, but also what I call a super shot and the super mode, and the super mode here is what's used to handle the quick shot. And the key thing in here is the so-called Gimbal Manager, which is integrated now in the STorM32 firmware, which you can use and which really coordinates or allows to properly coordinate all this gimbal control information and so forth, and also gives you this super shot possibilities. So this was everything I wanted to show you. I hope it was of some interest to you. Have fun and see you the next time. Bye bye.